Hello everybody, welcome into another lesson. So today we are going to talk about finding the length of an arc of a circle as well as finding the area of a sector of a circle. Now in the previous course in geometry, once again we only dealt in degrees. So the old formula for arc length in geometry was based on degrees. So it was literally the length of the arc would be equal to 2 pi r times the number of degrees out of 360 degrees. It was all based on degrees because arc length you could think of as a partial circumference, right? It's only the circumference of part of a circle, not for the whole circle. So it was based all on degree measurement. Well, with trigonometry here and using radians, there's an even simpler formula. The arc length is S equals r theta, where S is, of course, your arc length, r is your radius, and theta is your angle in radians. So your angle has to be in radians for this formula to work. S equals r theta. And then likewise in geometry, we also have a formula for area of a sector. So the geometry formula for area of a sector, of course, was the area equaled pi r squared times the number of degrees all over 360 degrees. So that was based again on degrees. Well, here in trigonometry, the area of a sector is 1/2 of your radius squared times theta, which again, your angle theta must be in radians for this new formula to work. And of course, we could think of the area of the sector as being an area of part of the circle as opposed to the whole circle. So let's do some examples here, okay? So here, I've already drawn the first one. You have a radius of 3 inches. Your angle, and they're nice and they give it to you in radians for this one. Your angle is going to be pi over 4. So we are finding the arc length first of this arc here from 0 to pi over 4. We want to find the length of that arc. So of course x equals r theta, which would have to mean that's the radius of 3 inches times pi over 4, or simply put, it's going to be 3 pi over 4 inches. So the length of this arc would be 3 pi over 4 inches. And if you really care to get a decimal approximation, you can do that. Now what about the area of the sector, which would be this whole region here? So the area is going to be 1/2, of course, of your radius squared times theta. So in this case, that's 1/2 times your radius of 3 inches squared times your theta of pi over 4. So what you should get for your area is going to be 9 pi over 8 square inches. So your area of this sector would be 9 pi over 8 square inches would be the area of this sector. And of course you can get a decimal approximation for that if you so choose. And I got more of this. Alright, let's see what we got next. So let's see, the radius equals 3 feet. So the radius is 3 feet, and your theta is going to be pi over 18. So we have an angle of pi over 18, which, as we know, would be 10 degrees. 10 degrees would be right here. So we're going to find the arc length of this piece right here. That's going to be pi over 18. It would be right here. So the arc length S is going to equal my radius of 3 feet times my theta of pi over 18, which means I have an arc length of pi over 6 feet. So I would have an arc length of pi over 6 feet for my arc length there. Now let's find the area of this sector. The area is going to equal, of course, half of my radius, which is 3 feet squared, times my theta of pi over 18. So this would end up giving me 9 pi feet squared all over 36, which means my area would have to be pi over 4 feet squared. So I get an area of the sector of pi over 4 feet squared. All right. What's the next one they're going to throw at us? All right, so we have a radius of 2 centimeters. Theta is equal to 9 pi over 20. So my theta is 9 pi over 20. So I'm going to try to figure out where that is in degrees so I can draw and illustrate. Let me just convert that 9 pi over 20 to degrees temporarily. Well, let's see, the pi's cancel out. 20 goes into 189 times, so this would be 81 degrees. So roughly right here, I'm going to be finding the arc length of this whole piece right here. I'm going to be finding the arc length of all this. That's roughly 81 degrees there. So that's a lone arc length. Okay. Now let's keep it in radian form for our formula. So the arc length for this whole length here is going to be my radius of 2 centimeters times my theta of 9 pi over 20, which should simplify into 9 pi over 10 centimeters. So that means I have an arc length of 9 pi over 10 centimeters. Now I can find the area of this whole sector if I take 1/2 times that radius of 2 centimeters to the second power times my theta of 9 pi over 20. So let's see. Well, I don't know why I have that to the fourth. That should be to the second, excuse me. So 2 centimeters squared is 4. Well, 4 divided by 2 is going to be 2. So that'd be 2 times 9 pi over 20, which I should specify would be 9 pi over 10 square centimeters. So the area of this sector would in fact be 9 pi over 10 square centimeters. All right. Good one. So we have a radius of 12 inches. We have a theta of 90 degrees. Well, it's good they initially give it to us in degrees because we can easily find that. So we're basically finding a whole quarter circle. We're finding the arc length for a whole quarter circle, and then the area of the sector of a whole quarter circle. But we need this to be in radians because that's how the formula works. So if we take 90 times pi over 180 degrees, you would simply end up getting pi over 2 for your theta. So now you have it in radians of pi over 2. So now we can find the length of this arc, which is going to be my radius of 12 inches times my theta of pi over 2, which means my arc length would be 6 pi inches. So the length of this arc would be 6 pi inches then. Now let's find the area of this whole sector. So that's going to equal 1/2 of my radius of 12 inches raised to the second power times my theta of pi over 2. So that would equal 1/2 of 144 inches squared times another pi over 2. So 144 divided by 4 is going to be 36. So I should end up getting 36 pi square inches. So the area of this sector would be 36 pi square inches, is exactly what I'd have. So I'm actually glad they gave it to us in degrees so we can see what the heck that looks like. Alright. What's the next one? We have a radius of 5 meters. My theta equals 120 degrees. So I have a theta of 120 degrees with a radius of 5 meters. Well, let's convert that theta into radians. So this would be times pi over 180, which would end up being 2 pi over 3 radians. So my theta is 2 pi over 3, which would be right here. That's where my terminal side would go. So I'm finding the length of this whole entire arc right here, as well as the area of this whole sector. So my arc length will be S, of course, equals my radius of 5 centimeters times my theta of 2 pi over 3, which means I have an arc length of 10 pi over 3 centimeters. And if you care to, you can get a decimal approximation, but that's my arc length. It'd be 10 pi over 3 centimeters. Now let's find the area of this whole region here, the area of the sector. So that's going to equal 1/2 of my radius, which is 5 meters. Where did I get centimeters from? Excuse me, that should be meters. Big difference in units. That should be 10 pi over 3 meters. So this would be half of 5 meters to the second power times my theta of 2 pi over 3. Well, good news, my 2's cancel out. So this should literally give me 25 pi over 3 square meters for the area of this sector. So 25 pi over 3 square meters is exactly what I should get for the area. I think I only got about 4 more, then we'll be done. Alright. So I have a radius of 15 millimeters. My theta equals 175 degrees, which I can tell you 175 degrees is going to be right here. Each of these little pegs is a 5-degree difference. So it's going to look like that, but that means I'm finding the arc length of this whole thing here from the initial side in the area of this entire sector. So that's going to be a humongous area. But let's convert that into radians. So that'd be times pi over 180 degrees. The best we can do is divide by 5, which let me feel what that is here. They're both only reducible by 5. That's all they have in common. 175 divided by 5 gives you 35. So this would give you 35 pi out of 36 radians. So in radians, this is 35 pi out of 36 radians. So now let's go ahead and find the length of the arc. That's going to equal my arc length of 15 millimeters. Not my arc length, my radius of 15 millimeters times my theta of 35 pi over 36, which I know 15 and 36 are both reducible by 3. That would turn into 5 over 12. So 35 times 5, let's see, that should be, I think 175. Yep. That would give me 175 pi over 12 millimeters. And would this reduce anymore? No, it wouldn't. That's the best you could get. So your arc length is going to be 175 pi divided by 12 millimeters. So that's just for the length of this whole arc here. Now let's find the area of this sector. So that's going to equal 1/2 of that radius of 15 millimeters raised to the second power times my theta of 35 pi over 36, which is going to be 1/2 of 225 millimeters squared times 35 pi over 36, which this is going to be rather hideous. Let's figure out what 225 times 35 is. 7,875. All right, so 7,875 all over 72. Well, 7,875 pi over 72 millimeters squared, which I would be shocked if that divided by 3 at all. Yes, it does. Wow. That's actually going to reduce to 2,625 pi over 24 millimeters squared. Doesn't that divide any further? It actually does. Wow. So this will actually divide even further. Because we always want to simplify if possible. That would be equal to 875 pi over 8 millimeters squared for my area of this sector. So 875 pi over 8 millimeters squared is the area of the sector. All right, 3 more. I have a radius of 4 feet. My theta equals 200 degrees. So my theta equals 200 degrees, which I can tell you 185, 190, 195, 200. So 200 is going to be right here on the unit circle, which means we're going to be finding the arc length and the area of this entire bad boy. So the whole arc length of this and the area of this whole sector. So that just got very big very fast. But for the formula to work, we need to convert that 200 degrees into radians. So take that times your pi over 180 degrees, which would be equal to 10 pi over 9. So theta is equal to 10 pi over 9. That's going to be 200 degrees. All right. So let's find the arc length. That's equal to my radius of 4 feet. So 4 feet times 10 pi over 9. That gives me an exact arc length of 40 pi all over 9 feet. So there's my arc length of 40 pi over 9 feet. Now, let's find the area of this whole sector. So that's going to equal 1/2 of that radius of 4 feet to the second power times that 10 pi over 9. So this is going to equal 1/2 of 16 feet squared times 10 pi all over 9, which 16 divided by 2 is 8. That means my area is equal to 80 pi all over 9 feet squared. So my area equals 80 pi over 9 square feet. That would be the area of the sector. I got 2 more. Radius equals 16 centimeters. This is a lot tamer. My theta equals 50 degrees. My theta is 50, which would put that right here. So I'm only going to find this arc length. I'm only finding the arc length of this region in this area of this sector. So theta is 50, but I do need to convert this into radians for the formula to work. So this will be times pi over 180 degrees, which would simply give me 5 pi over 18. So my theta would be 5 pi over 18 in radians. Okay, now let's go ahead and do this. So let's find the arc length. So S equals my radius of 16 centimeters times my theta of 5 pi over 18. Well, 16 and 18 are both divisible by 2, so that would give me 8 and then 9. So that means my arc length would be 40 pi over 9 centimeters. So I have an arc length of 40 pi over 9 centimeters. Now let's find the area. Area equals 1/2 of that radius of 16 centimeters, which is squared, times that theta of 40 pi over 9. No, wait, that's 5 pi over 9. I just plugged in my arc length for some reason. That'd be 5 pi over 9. Excuse me. Alright, much better. So this would be 1/2 of 256 square centimeters times 5 pi over 9. Half of 256, that should be, I want to say 128. Yep, so that's going to be 128 square centimeters times 5 pi over 9. Which, let's see what we get when we do 128 times 5. 640. So you would get 640 pi over 9 square centimeters. Which, let's see if that 640 over 9 can reduce any further. Nope. So that's the best we got here. The area of that sector is going to be 640 pi all over 9 square centimeters. And I got one more and we're done. All right. Big one. So we have a radius of 20 feet. I have a radius of 20 feet. My theta equals 270 degrees. So that's going to be a big area and a big arc length. Let's convert that 270 into radians. So this would be times pi over 180, which would give me 3 pi over 2. So my theta is equal to 3 pi over 2 in radians. So that means I'm going to literally then, let me show you what we're working with here. So we are finding the entire arc length from here all the way down to here in the area of this sector. So that's a rather large area. So let's go ahead and get started with the arc length. So S equals my radius of 20 feet times my theta of 3 pi over 2, which means I'll end up getting 30 pi feet. So my arc length would be 30 pi feet. Now let's see if we can find the area. So the area would equal 1/2 of that radius of 20 feet raised to the second power times my theta of 3 pi over 2. Alright, well 200 squared is 400, so this would be equal to half of 400 square feet times 3 pi over 2. While in the denominator 2 times 2 is 4, 400 divided by 4 is 100. So I should get 300 pi square feet. So the area of that sector should end up being 300 pi square feet for this whole area. Alright, so that's it for arc length and area of a sector. Next lesson, we're going to get into more about the unit circle and the 6 trig functions in relation to them. So I hope everyone has a great night. Take care.